All right, hello, Mallory and Chloe. This is the 7-2 we did yesterday. We're going to go through questions over 7-2, but I thought I would record it in case you guys had these same questions. And then here in a little bit, we're going to do some whiteboards. So we don't have a very long class period. I'm not going to do a new lesson. We're just going to go over whiteboards, okay? So we're going to start with number 11, somebody said. Sorry, I'm losing my voice. Okay, we are adding and subtracting. In this case, we're subtracting, okay? I told you yesterday that when you're subtracting, to prevent you from doing things wrong, I changed this to plus and I put the minus up there with the 9. You remember that? Mm-hmm. Okay, now we have to find our common denominator with 5y squared and 5yz squared, okay? So, out of the numbers, 5 and 5, what's my common denominator going to be, my least common multiple? 5, right? 5 goes into 5 and 5 goes into 5, okay? Now, as far as y's go, how many y's will I need? I will need 2 of them. If I don't have 2, like if I only put 1 down here, will this go into that? No, I need to have 2 of them, right? But if I have 2 of them, will this go into that? Yeah. Sure. Okay. So I need a y squared, and I need a y squared. And z's, how many z's do I need? 2, right? This doesn't have any z's to go into, but this one has a z, and he will go into there if I have a z squared. So this is my least common multiple, and I write him twice, okay? Like just one right next to the other, okay? Then I start with my 11 and my negative 9, okay? Those you guys just stay the same, but then I multiply by what he's missing, okay? So I put my little parentheses there, and we're just going to compare. So I am comparing 5y squared with this right here, right? So 5y squared is what he has right now. What does he need? He needs a z squared, so I'm just going to put z squared in that box. Does that make sense? Okay? Now this guy right here, compared with this guy, what is he missing? He needs a y, right? Okay. All right, now I'm just going to write it all over top of one roof. So my bottom number should just be 5y squared z squared. Okay. And then on the top, if I take 11 times z squared, that's 11z squared. What about this guy? Minus 9y. Okay. Can you put those two together on the top? No, they're not like terms. Z and y are not the same, so we just leave them like this. Does that make sense? Okay. Yeah, not too bad. Okay. All right, what else do you have?
Like everything on the back.
The whole back? Yeah. The whole back. Oh my goodness. Okay, the whole back. Here we go. Number 13. 13 is a really good one.
I got them done.
Check them. Sure. That's great. Okay. All right, number 13. This is another, goodness sakes. This is another subtraction one, right? So I'm going to do plus minus 7, right? I'm going to move that negative up there, okay? All right, so I have my 2 pieces, and I need to find my common denominator, or my least common multiple. So I know in my denominator I have to have an a plus 2, right? Okay? So I'm going to put a plus 2, a plus 2. And I know I also need 5a, but here's the deal. I already have an a down here. So we just need a 5? How does that work? Like, can I just get away with doing like a 5 there or whatever? And a 5 here? Okay, here's the deal. This a right here is not trapped. This a right here is a trapped a. They are entirely different A's, so they might as well be A and B instead, right? Like, they're not the same A. So I need an A on my 5 as well, because one of them is a trapped A and one of them is not a trapped A. So they are entirely different A's. Does that make sense? Okay, so I just need both pieces. I need A plus 2 and 5A. Got it? Ooh, I have a mess. All right, so let's start with our 12 and our negative 7. And then let's multiply by what he needs. So this guy right here, we're comparing a plus 2.
5A.
He needs a 5a, so I'm going to put a 5a here. Okay? Let's bump over to the 7. What does the 7 need? A plus 2, right? He goes in the bubble. Okay? All right, now let's put them all under one roof. I've got a plus 2 and 5a on the bottom. I'll just put 5a right here. Okay? All right. If I take 12 times 5a, that's 60a. Okay, now, if I take negative 7 times a, minus 7a, what's negative 7 times 2? Minus 14, okay? Done? Is there any like terms I can combine?
No.
60 and 7.
60a and minus 7a. That is
53A.
53a minus 14 all over the junk again. There we go. Does that make sense?
Yeah.
Okay, multiply by what he needs, combine like terms. That's it. Okay? All right. Shall we keep it?
Which day is it?
Any? Do you want me to just keep moving on down the line, or you want to like skip any of them? Okay, 15. Here's another minus, so I'm going to do plus minus 3. Okay, move that negative up to the 3. All right, these guys are trapped, right? These are trapped denominators. So I have w minus 3 and w squared minus 9. This is a difference of squares. That's the first strategy for trapped is you break him down, right? So if he's a difference of squares, what will it look like? Broken down.
W minus 3, x plus 3.
Yep, w minus 3, w plus 3. Yep, you're fine. If you don't like the w's, I'm not picky. If you switch them back to x's, I don't care. Okay, so now we just have to find our common denominator, or least common multiple. I know that I need w minus 3, right? Okay, if I bump over to my second one, I know I need w minus 3. But I already have one, right? Okay, then I know I need a w plus 3. So if that's my least common multiple, does this guy fit into there? Does this guy fit into there? Yeah, so I did it right. Okay, all right, so w minus 3, w plus 3. I'm just going to rewrite him over here, okay? All right, my numerators are 3 and negative 3. And I'm going to write what he needs. Okay? All right, w minus 3 is what he has now. What does he need? He needs a w plus 3, okay? Here, that's what he has. That's what he needs to be. What does he need? Nothing. So I'm going to cross that off, or you can put 1 in that box if you want to, okay? All right, so up top here, I know that my bottom is going to be w minus 3 and w plus 3. You don't have to multiply those back together unless you really want to. I don't care. Okay? On the top, I take 3 times w and 3 times 3. 3w plus 9. And then what else? Minus 3. So 3w plus 6 is what he will become if you combine the 9 and the 3. Okay? Now, if you guys can do that in less steps or whatever, like, you know, like if you just want to erase this and not have to rewrite it, I don't care. I don't care. That's fine. Okay? Good? Happy with that? All right. Just truck it on down. 17. 17, this is another minus 1, so I'm going to change it to plus minus 8. Okay?
What?
Are these bottoms trapped or not trapped?
72?
Not trapped.
Not trapped. Not trapped. So we're just looking at this guy and this guy. Okay? All right. Starting with K's. I just go across the board. How many K's will I need?
2.
I need 2 K's, right? How many N's will I need?
1.
Just 1. So, like, does this fit into there?
Yeah.
Does this fit into there? You betcha. Okay? Got it? We got a K here and a minus 8 here, and we're going to multiply by what he needs. Is this getting easier, kind of?
K. You need K.
Okay, this guy is going to need an extra K, so we got K and K, right? That's only 2 Ks, sorry. You're out. Negative 8.
K.
What does the negative 8 need?
Nothing.
He doesn't need anything, so you can put a 1 in that spot, or you can just get rid of him. Okay, so what's my top look like? K squared
Minus 8.
minus 8 over
K squared n.
K squared n. Now, question, can I cancel this K squared with this K squared?
No.
The bottom one's not trapped, but the top one is, so nope. Okay, K, that's a lot of
okay.
K's. K.
K.
All right,
Okay.
good? That was 17. Is this getting easier as we go along? All right, 19.
Oh, we do it.
This one looks ugly. Is this the last one? Nope, we've got 21. 19. All right, are these bottoms trapped or not trapped?
Trapped.
Trapped, what do you do when they're trapped?
And Jesus.
Break them down. I like break them down, okay? So this guy is a simple trinomial. Broken down, multiply to get 1, add to get 2, x plus 1, x minus 1. Or excuse me, x plus 1, x plus 1. They're 2 plus 1s. Oh, this is the one that I gave you as an example the other day. Do you remember this? This guy's broken down. He's good to go, okay? All right. This is the exception to the rule. Do you guys remember I gave you an example on the notes? 2 days ago when we did this in class, the exception to the rule. So when I'm going through, I know I need an x plus 1. Okay? If I go to my second piece, I know I need an x plus 1.
Yep.
There's already one there, but I will need a second x plus 1 because otherwise this guy won't fit into there, right? 2 can't fit into 1. So because they're in the same piece, I do need to have 2 of the x plus 1s. Does that make sense? All right, now, this one, if I bump over here, I need to have an x plus 1, but I already have 1. So does he fit into there? Yeah, right? Okay. So x plus 1, x plus 1. That's my least common multiple. Here we're adding, so we don't need to do the plus minus thing. I've just got 4x and 2. Yeah? All right, what he needs. Okay? The first one,
Nothing.
he doesn't need anything, so we're going to cross him off. The second one, what does the 2 need?
X plus 1.
He needs another x plus 1.
X.
Am I going too fast?
No.
Nope. Okay, so the top, I've got 4x plus, distribute your 2 through,
2x plus 1.
2x plus 2, okay?
So
And then on the bottom is x plus 1, right? Okay, so combining like terms, I heard Toby say you got to put them all together, and that is 6x plus 2 and x plus 1, right?
Oh, can you just write x plus 1 squared?
You can. That's a good thought. So Gordon says, instead of writing it like this, could I write it as x plus 1 squared? Isn't that what x plus 1 times x plus 1 means? Sure, yeah, that's fine. You can write it like that. Good.
Just too smart.
Just too smart.
Well, I just saw like.
Can you ask someone how you did it?
No. I mean.
All right, should we go through the last one, 21?
X times x.
Are we feeling better about this, maybe?
This one is also.
Mrs. Hunter,
Yes, ma'am.
if I do this right now,
Hey, sir.
like while you're
How you
still
did it?
talking, can I go off?
Sure, that's fine. Okay. All right, so trapped or not trapped? Trapped. The bottoms are trapped.